Okay, a capillary is a blood vessel, and then fat cells. Okay, there's our adipose tissue within, or not, I shouldn't say adipose tissue. It's not the tissue; it's the cell. But here's a globulate of fat within um, a connective tissue. So there are fat cells within the different connective tissues in the loose connective category. What else? So then just some more, one of my favorite ones, macrophages. Like, they're so cute. They kind of look like neurons, and I love neurons. But a macrophage, you may recall, is going to get rid of stuff. Oh yeah, trash collection. That's what I'm talking about. You have to have great respect for those who come and help you remove your trash and your recycling from your household, right? Like, wow, thank you. Thank you. So the macrophage is like that. The macrophage is going to clean up any debris after an insult or something that comes along that's not needed. It also will clean up any debris from metabolic waste as well, just on a daily basis. All right. Cells, here comes these definitions again. But the blast is the immature cell that actively secretes the ground substance, right? This is just extra cellular matrix fibers. The fibroblasts, right, are going to be the immature cells in connective tissue proper with like a fibrous secretion. This will have the cartilaginous secretion, and this is the bone. So this is just found in, see how the bone builders are found in the bone, the cartilage builders are found in the cartilage. What about site? It's the mature cell. It's less active as far as mitosis goes, so it's not reproducing or creating as often, if at all. And it's going to work and function to maintain the daily health. What do fat cells do in there in the connective tissues? They store nutrients. White blood cells are going to be a part of the immune response. Mast cells are part of the inflammatory response, which can also be part of the immune response. And then we get to macrophages, and it's the same thing here. We have something that's also a part of an immune response, because once you start initiating these processes, you are going to end up with byproduct, right? As soon as you start creating, you have byproduct, and the phagocytes are going to take away anything that is not needed in that area anymore. So this is just them again, looking at those cells. So they're all working together as a team for the best results for the function of the tissue, right? So all these cells are going to be working together for the function of the tissue. We went through these types already in images, but here they are in a slide for your viewing pleasure. And I love this, okay? So we are in connective tissue proper right now, looking at the, ooh, hello. There's 1, 2, 3, 4. That's what you saw on the last slide. We get into loose and dense, and we have this flow chart to kind of keep us organized. I like it. So areolar, adipose, and reticular. This is a flow chart in a different form. That's all this is. Okay. Now, this is a bit about areolar tissue, and this is a lot of words, right? So I'm just going to point out the basics. So it is found all over the body. It's pervasive as far as a tissue goes. It's going to be a loose and delicate, a thin type of tissue. There's many cells and fiber types within it, right? And we have that, we saw the ground substances. So what is it going to do? It's going to support and bind like fibers do. It fills in the spaces between muscles, right? And it is going to be part of any sort of infection, fighting when an onslaught comes up, a bacteria is introduced, something like this. We're going to have an immune response start in this tissue. Okay, so that's areolar connective tissue in a nutshell. This is what it looked like in our microscopic images, right? So it's showing you that there's epithelial tissue and the lamina proper, which is the connective tissue basement membrane. So epithelials are often adhered to areolar tissue. There is the holding of tissue fluid. Um, it provides a reservoir of tissue fluid. So water and salts, because of its loss, its nature of water and salt, right? Okay, what I want to say is this. Depending on any concentration within the body, the amount of fluid in a space can move or change, right? So, so areolar tissue will be responsive to that. That's all I want to say. So, when a concentration of salt is high outside of the area, it's going to draw water out, and when it's low, it will draw it in. Let's look at this. Excess loss of blood fluid to interstitial space. Okay, so this is edema. This is probably something many of you had seen in work, right? And you have to stage it with like mild, moderate, or severe. And if you can imagine that blood, which we'll look at, has fluid in it, and that fluid can be removed from the blood and go somewhere else, it can go into the areolar tissue. So when you take fluid out of the blood into the areolar tissue, you get this look or this image. And if you've never seen this before, um, it doesn't always pit. This is a picture of pitting edema, but it's got a boggy feel to it, and yeah, you'll see it often in the ankles. But there can be edema around any area. So after a hip surgery, for example, you'll have edema in the areolar connective tissue around around where the surgery took place.